hydrogen, deuterium. You know those symbols, right? You know those symbols, right? Deuterium means 2. Sorry, not. Okay. Similarly, ionized helium. Helium symbol, these things you know, right? For ionized lithium. Plus, double E. All have electron around consider an electron transition are lambda 1, lambda 2, lambda 3, and lambda 4, respectively. Approximately, which one of following is correct? Okay, read the question, think. I'll give you here option because we need which of the following they are saying. Okay, but let's give a condition also. Consider an electron transition from n equals to 2 to n equals to 1. So these are the lambdas. No electron transmission. These are wavelength. Wavelength of these radiations are. So option A, 4 lambda 1 equals to 2, lambda 2 equals to 2, lambda 3 equals to lambda 4. B, lambda 1 equals to 2, lambda 2 equals to 2, lambda 3 equals to lambda 4. C equals to lambda 2 equals to 4 lambda 3 equals to 9 lambda 4. Lambda 1 equals to lambda 2 equals to 3 equals to. Okay, think this question. Are you trying, guys? Are you there? Devendra, Niyati, Saksham, Shrisa. Are you all there? You're solving, right? Yes or no? If you don't, like, no, I can solve it here. Tell me. Are you all there? Can you hear me? Yes or no? Lambda r z squared. And 2 square. Lambda is proportional to 1 by z square. N is 1 and 1 is 2. Okay. So if I substitute here, proportional here, reverse. So with this one, we can say 1. So lambda 1 equals to lambda 2. Then 4 lambda 3. 9 lambda 4. Option number C. What is option C? Yeah, this question we can do. State is excited by a tick radiation of lambda equals to 975 Armstrong. The number of spectral in resulting spectrum anyone solved or doing it? So lambda is 975 Armstrong. R n1 square by n2 square. Substitute the values, you'll get this. Yeah, quickly do it. Are you there or not? Still no reply. Shall I do? Substitute and get me answer. What is R here? Randburg constant. Put the value I'm going to scroll up. For this one, N1 and N2 will be 4. I mean N. N1 is 1 actually because it's in ground still. 1. So if we make this series, n minus 1 divided by 2, 4 into 4 into 3 by 2, which is 6. Let's do next topic. Yeah, this is the next important nuclei. Let's have a quick revision on this. Okay. What is nuclei? Okay, first let's write just chapter formulas, combine all formulas. Nucleus is what? Proton and neutron. Composition of nucleus. Proton plus neutron. Size of equals to radius equals to r naught a 1 by 3. R naught value you should know. How much? 1.1 minus 15. Density rho 3m by 4 pi r naught cube. If you divide this, you will get 2.3 into 10 to power 17 kilogram per meter cube. Number of nucleons is today's mass of proton plus neutron. Per unit volume into power 44 nucleons per meter cube. So mass of proton, if you remember, 1.67 into 10 to power minus 27 kilogram. Mass of neutron, 1 point same. Mass of electron, which is different, 9.1. These three things we should remember. You know all this, right? Not make a note, remember it. Atomic mass unit. AMU. 1 AMU equals to 1 by 12 of mass of C612 atom. One AMU, atomic mass unit, equals to 1,931 mega electron volt. And if we convert this one in AMU, so it can be like 1.007 U, 1.0082, 0.005 U, which is 9.8. And U value is 1.66 into 10 to the power minus 27. Nuclear, do you know? ZA. This is what? Atomic mass, which is proton plus neutron. This is what? Atomic number or number of protons. Nuclear stability. And by Z ratio, which is equals to 1, so it is nuclear stable. And this, and by Z equals to 1, which is stable. Or lighter nuclear. For heavier, they have more than proton. So that's time it is stable. When neutrons are more than protons, it is stable. In this one only, we are going to study what mass defect, binding energy, half-life, decade, alpha decays, alpha beta decay, gamma decays, nuclear energy, all these things. In this, half-lives are most important. Mass defect. Sum of masses minus mass of nucleus. Binding energy EB equals to delta M E square. binding energy per nucleon equals to total binding by mass number, MeV by nucleon. So binding is proportional to stability of nucleons. If we draw a graph for this one, let's mark here. This is some 0.8 for oxygen. Here C 12. This point is almost 56. 100, 150, and so on. This, let's see, this is 2, 4, 6, 8. Done? Radioactive series. So I'm saying, if you have any topic to discuss, if you want to know some of the topic, like let's do some numerical on that, you can text me, whatever. You all can hear me, right? I hope so. If you go with the series, you can remember like the table. Thorium mass number is 4n, this one, pH 232, isotopes stable at point PB 208. This table you know, right? It is natural. Neptunium 4n plus 1 and B 237, 23. Bismuth 83, 208. Sorry, 9. Next, right? 209. This is artificial. And so on, like uranium U238, 92, 238, PV 206. Same, it goes on. Stable. These are the stable end product. Radioactivity means disintegration of heavy elements into lighter element. That means emission of alpha, beta, and gamma radiation. This for emission. So what are alpha decay? They are ionized helium. Emission of alpha particle decrease atomic size decrease by 2 and number decrease by 4. Atomic size decrease by 2, so decrease by 4, beta decay. They are fast moving. So after one particle moves or it emits or emission of one beta particle. So what happens, like atomic number increase by 1, but number no change. Gamma decay. So there is no change in any of this. Rate of decay. No. Proportional to 1. So dn dt equals to lambda n. Number of undecayed atoms n equals to NOE minus lambda t. Half-life. Half-life is what? It's about 0.693 by lambda. Mean life tau equals to 1 by lambda, which is 1 by this we wrote, right? This will go, that side will become t 1 by 2 0.693. So period of undecayed atom and becomes 1 by E times, or 0.37 times of original number. I'll post one like a photograph later on. You can check those things. Now we'll do some nuclear energy. But in exam, mostly it will be coming from this half-life questions. Let's directly do those. Okay, alpha particle consists of, it was asked in 2000, which is this 19 NEET exam. Alpha particle consists of H plus plus, He plus plus. That means 2 proton, 2 neutron. So in option we have 2 proton, 2 neutron only, 2 electron, 2 proton, 2 neutron, 2 electron, 4 proton, 2 proton only. So obviously, this is obvious answer. Okay, let's try this question. It's good. It was asked in last year. Activity of a sample falls from second inverse. Inverse to yes, guys. What formula? E to power t. Lambda equals to ln 2 1 by 2. Shall I solve? Okay. 500, 700, e to power. You have to substitute this value, right? Minus t minus t ln of 2 divided by t12. Seven by 5 by 6. So if I send this e on that side, it will become ln. If I send e on that side, it will become ln of 7 by 5 equals to t, how much? 30 minutes, right? Okay. 30 ln of 2 divided by ln of this is 1.4. No, this answer I gave. Ln of 2 is 0.969. This we need to remember. And ln of 1.4 is 0.33. Generally, we will get this values only. Not every time, but generally. So it will be approximately 61.8. Then Shall I go next question? Okay. Okay, we have time, right? In your maths class. Okay. Half-life is half-life of radioactive isotope X is 50 years. Decay to another. This Y element is stable. Two element X and Y are found in ratio 1:15 in a sample of rock. Estimate age of. So what they're saying, I'll read the question again. The half-life of radioactive isotope X is 50 years. It decays to another element Y, which is stable. The two elements X and Y were found to be in ratio of 1:15 in sample of given rock. The age of rock was estimated to be 150, 200, 250, 100. That's what we need to find out. So we don't know number of atom or nothing we know, right? So we can, let's assume something, nx number of atoms in X and Y number of atom in Y. So we have ratio as 1:15. So nx by ny equals to 1/15. But as per the question, it is stable now. It decayed to another element Y. So n of x equals to 1/16 of n of x n of y. And plus 1/15. So next is 2 to the power 4 n of x plus n of y. So total 4 half-life. So 4 into 50 years, which is 200. 4 half-life passed, so age of rock is 200 years. And out in this question, we'll do some more question next class. Because now you have to join for maths class.